It's there.
All
right, take a look at your answers. For here, all right, sine of 60, square root of 3 over 2. Cosine of 270, 0. Tangent of 225 should be 1. Sine of 240 is negative radical 3 over 2. Tangent of 150 is negative square root of 3 over 3. Cosecant 210 is negative 2. Secant of 150 is negative 2 radical 3 over 3. And cotangent of 180 is undefined. Secant of 315 is radical 2. And then cotangent of 330 is negative square root of 3. Okay. Sometimes you're able to do these. I would suggest, if it doesn't come to you regularly, I'd write each one down. You draw out the circle if you need to. So like for number 7, the secant of 150, 150 degrees. What we need is the reference angle, which is going to be 30 because we're going to go 150 degrees to get to there. Okay, that's where the initial angle is. Drop this down, 30, 60, 90 triangle. Your hypotenuse is always 1. Across from that's 1/2. Square root of 3 over 2 would be across from the 60. So that coordinate would be negative radical 3 over 2 comma 1/2. The secant is 1 over x. You need to know those. Sine is y, cosine is x. Tangent is y over x. Cosecant is 1 over y. Secant is 1 over x. And cotangent is x over y. So you need to know those. The x coordinate would be negative square root of 3 over 2. So the secant of 150 is 1 over negative radical 3 over 2. And when you get done with everything, negative 2 square root of 3 over 3. Okay, for that one. But I would set each one up until you get a little more comfortable. And even sometimes you're always going to set it up. It doesn't matter for those. Okay. Any other questions for those? Okay. All right, now let's take a look here. We're going to graph sine and cosine. And all right, so we're on those guided notes. All right, first thing. Okay, let's do this first. I'm going to just switch this order. Okay. All right, a periodic function. Something that's periodic. It's just going to repeat itself. It's repeat itself over and over and over again. The positive number p is going to be called the period. That's how when it starts to cycle back over. The graph of f over the interval of length p is called one cycle of the graph. So we're going to go through that. Now, what does the graph of sine look like? All right, first of all, let's just kind of get an idea using the unit circle. The sine, Jade, is which coordinate? Jade, which?
Sine is y.
Yep. So the sine of theta equals y. So if we're in radians at 0 degrees, what is my y coordinate? At 0 degrees or 0 radians, my y coordinate is what? It is 0. So when I plug in 0, I get back 0. Now it's going to travel. We're going to take this angle at different spots. Okay, so think about the y coordinate here. Is my y coordinate getting bigger or smaller? It's getting bigger until it gets to 90 degrees. And at 90 degrees, or pi over 2 radians, what does it get to? 1. So pi over 2, it gets to 1. And now my y coordinate, you take a look at that, will start to get smaller until it gets to pi. What is it at pi? 0. And then at 3 pi over 2, okay, now I keep going. My y coordinate is negative until we get to 270, and it's going to be -1, and then we go back to 2 pi where it is 0. All right, so now let's take a look. At this. Okay, so here's 0 pi over 2 pi, 3 pi over 2. This is our unit circle. Okay, you want to think what the y coordinate is as it rotates around. Hold on. Okay. So now it's going to graph it. Okay, so now right there, it goes up to 1. What do I want on that? There we go, I didn't want that. So it's graphing that y coordinate, the height of it. So the height, what's the highest it gets from there? Clearly the highest it gets is 1. What's the lowest it gets? -1. The lowest it gets is -1. Okay, so it's going to travel in between there. And so this is just going to be the corresponding y coordinates. And it's just going to keep repeating. It's going to keep repeating. And it actually will keep going past 4 pi, but it just stops for here. It also goes to the left as well. But it kind of gives you an idea of what it looks like, all based upon just traveling around the unit circle. What is the y coordinate? Okay. Now, what I need you to do is you're going to need to know the graph from -2 pi to 2 pi. Well, it just keeps repeating, and so from -2 pi to 0, it's just going to be the same figure. So graph this as accurate as you can on that very top graph. Let every x interval be a pi over 2. So it's going to go from -2 pi to -3 pi over 2 to -pi, to -pi over 2 to 0. Just like I have up here. I would probably make it go up a little bit higher than just 1. So I'd actually maybe let go up to the second mark just to spread it out a little bit. Not that you have to, but graph that on there. And it starts at 0 at -2 pi. I just had to cut and paste there. That's why you get that little bit of extra piece there. And so it's always going to go from, it starts at 0 and it'll go up to 1 and then back to 0 and then down to -1 and then to 0. Now make sure you draw as a curve. You can see it clearly on here. Don't make it like straight lines connected. There's no straight lines there. Everything's a curve. And then at 0, it goes back to, from 0 goes up to 1, back to 0, down to -1. So you want to draw that as neatly as you can because you're going to use that for the rest of the chapter. Okay, that is your base graph for sine. All right, you got those below there. You got period, you got domain, you got range. The period is the interval it takes to do one cycle. What would be the period of this graph? And then it repeats. The period is 2 pi. Okay, every 2 pi is going to do one of these cycles, and then it's going to repeat again. The domain is all real numbers. Because you can plug in any angle into there, you're going to get back an answer. In the range, we already said it has a high of 1 and a low of -1, so it's going to be -1 to 1, okay, for the range. All right, now there's one other thing we need to write down there that's not on there. Is it an even function or is it an odd function? And do you even remember what an even function is versus an odd function? It has to do with plugging in a negative angle. What happens when you plug in, like say 30 degrees and you plug in -30? You get the same answer, totally different answers, or opposite answers. So sine of 30. If you think of this as 30 degrees, the sine of 30 is 1/2. What's the sine of -30? Okay, when you drop that down there, you just go the other direction, but the sign is going to be what? Instead of 1/2, it's actually going to be -1/2. So it's -1/2. So they're opposites, which means it's going to be an odd function. It's going to be an odd function. All right, now the cosine graph. Oh, hold on. This isn't on your guided notes. Forgot about this. We're going to take a look at transformation. So just take a look at this. What should the 2 do to the graph? Okay, if we remember it. Cole?
Increase the amplitude by 2.
It's going to increase the amplitude. It's going to vertically stretch it. So the only thing it's going to do is move. Instead of going up to a height of 1, it's going to go to a height of 2. What about 3? That's going to increase the amplitude. What's the 2 going to do from in the past? Okay, it's going to change the Cole.
Compression is going to compress it inward.
It's going to compress it. Going to cut it, cut the period down. So instead of going from 0 to 2 pi, it's going to go from 0 to pi. Okay, and then this is going to shift it since it's a minus. Remember, it shifts it to the right. So normally it starts at 0, 0. Now it will go through 0 at pi over 2. So it shifted it to the right. So we'll hit all of those here as we kind of move forward. For cosine, I think I can just use the same one. I am going to cut that out, and let's see here. Cosine, okay, at 0 degrees, what is your x value? It is 1. So it's going to start up here at 1. Think what happens to the x value as we go from 0 to 90. The x value actually gets smaller until at 90 degrees it gets to 0. Oh, let's see here. So that is going to be the cosine, because think about the x coordinate right there. That's the x coordinate, and then that's the graph of it. Now it's negative, -1, down to 0, to +1. So it's going to continue that cycle. It looks the same, it just starts at a different point. All right, now from -2 pi to 2 pi. Okay, this is going to be what it looks like. Okay, start at, and even at -2 pi, it's going to start at 1, go to 0, -1, 0, back to 1. Period, again, will be 2 pi. That's how long it takes for it to recycle through there. Domain, -infinity to infinity. We're going to plug in everything, and your range is going to be the same as well, -1 to 1. All right, think about is it even or odd once you get it down. So you got your period, 2 pi, domain, negative infinity to infinity. Oh, let me do this. And it's going to be an even function. If you take a look at the cosine of the negative angle, it's going to be the same as the cosine of the angle. For that. Now that next figure down below there, this just kind of highlights the key points, which we'll kind of use throughout graphing. There's 5 key points for sine. The 0, the max, the 0, the min, and then the 0. So this is the basic graph of sine. Cosine looks different. It's basically the trough. Starts at the high, goes 0, low, 0, and high. So understand the difference. So if you're asked to graph one cycle of sine, your graph should look like this. If you're asked to graph one cycle of cosine, it should look like that. So it's a little bit different when you're just doing one cycle. On the bottom there, these are what we call sinusoidal graphs. Okay, so the graphs of the sine and cosine function, sometimes they're called wave graphs, but we call them sinusoidal graphs. All right, once you get that down, flip it over. All right, in general, we need to be able to identify the transformations. So if you got a constant in front, it's going to change the amplitude. Okay, technically we talk about the absolute value. It's going to how high it goes and how low it goes. Okay, for that. The phase shift or the period is 2 pi divided by that constant. So that's how we get a new period based upon the constant. Phase shift C moves left or right. D moves up or down, vertical shift. So depending on what you got, depending on whether you have a phase shift, a period, vertical shift. All right, for this first one here, you're going to have to be able to graph these without your calculator. I'll show you how to check them with it first. So go ahead and write that equation down. And then on your x-axis, so basically divide it from negative 2 pi to 2 pi, just like you did on the front. So hold on. So it'll go from negative 2 pi, and I know I don't have the grid on here, negative 3 pi over 2, negative pi over 2, 0, and then all the way to 2 pi. All right, so you have to graph it starting at negative 2 pi and then finishing it all the way to the right. All right, it might help for this first one to graph the sine function on here so you have it as a reference. So I'm going to do that. And so I'm going to start here, and I am going to go just up to 1 here. I'm going to use that as 1, and this is negative 1, and 0, and negative 1, 0, 1, 0, negative 1, and 0. All right, now if you look at the equation, I'm going to move it, see if I can move it down here. Okay. The first 2 is going to stretch it. But what does the negative do? Okay, remember what that negative does. It's going to reflect it over which axis? Okay. And the negative is out in front. Okay, it's going to reflect it over the x-axis. Okay. So our amplitude is going to be 2. It's going to reflect over the x-axis. And then this 2 with the x, it's going to change the period. So the period will be now 2 pi divided by 2, which is pi, which will do a full cycle. Okay, a full cycle from 0 over an interval of pi. Now it's not shifted left or right, which helps a little bit. Okay. So now here is one cycle from negative 2 pi to 0. That is one cycle. Now that will take place from negative 2 pi to negative pi. Okay, that whole thing. It's also going to be stretched to what? 2 and negative 2, and it's going to be flipped. So this is going to start right here. Where's my next key point going to be? Okay, it's usually right here, but it's going to be halfway in between there because it's getting compressed. And it's also going to go down to negative 2. So halfway in between there, it's going to hit at negative 2. And then at negative 3 pi 2, we're going to hit at 0. And then it's going to go up to 2, go back to 0. So this will be one cycle. One cycle. And then we're just going to repeat that pattern all the way to 2 pi, and then halfway down here, it's going to be negative 2 pi, then negative pi, or in between negative pi and negative pi over 2. Up here, 0. Okay, and then continue that pattern. For that, okay. Hey, pull your calculators out. Let's take a look at what it looks like on your calculator so you can double check it. You really have to watch. You're in physics or everything else. Sometimes we're going to be in radians in here. Sometimes we'll be in degrees. Typically in physics, you're going to want to be in degrees. So you got to watch. If things aren't looking like they're coming out correct on your calculator, you might have to check your mode. To change between radians and degrees, it's under the mode button, which is right next to the second button at the top. And it's the third one down. So go ahead and put it in radians. And now that's really going to affect your window, okay? Because normally it's like negative 10 to 10. We wanted from negative 2 pi to 2 pi for this one. So I already have it in there. If you hit negative 2 pi, it'll look like negative 2 pi. But once you hit enter, it'll convert it to the decimal. I'm just changing my window. So X min, make it negative 2 pi. X max is 2 pi. And then the interval is pi over 2. Whoops, that should be up my scale. Hold on, I screwed that up. I'm going to go back and fix that. That's wrong. So I'm going to do pi divided by 2. All right, for my y min, I'm actually just going to make it negative 2, and my y max. Oh, actually, yep, that'll work. 2. All right, once I got that, I'm going to go to y equals. And what was the equation? Negative 2 sine of 2x. And see if what we have up here matches. Okay, so it starts to go down and up, and we get all the cycles on it. Now, if you want to graph sine of x just to compare it, you can always plug in sine of x, hit graph, and then you'll see the original graph, how it compares to it. All right, that's if you are asked to graph it from negative 2 pi to 2 pi. You got to figure out any shifts or anything there and graph over the entire interval. All right, what does the next one say? It says, for the following, find the amplitude, period, phase shift, list of 5 key points. All right, the directions are going to be a little bit different. If you have your book handy, I would get it out and turn to page 568. it gives you it kind of walks you through how to graph one cycle. Are you using the book carrier? Are you using the book carrier?
She is. She is. Mine's at home. Yeah.
She doesn't have it today? Oh,
No.
Not good partners.
Nope.
Not good partners. All right, now this is key. It says graph this equation over a 1 period interval. And think of the period as starting at from 0 to 2 pi. So normally sine from 0 to 2 pi okay, looks like that. When we're done, we just need one cycle. That's what it should look like when we're done. But we got to find the coordinates of these points. Okay, so that's the main thing, the coordinate of the 5 key points. Now this, like I said, it walks you through it. We're going to do the exact same example. On the left-hand side, basically gives you the general instructions, and then on the right-hand side, it gives you the actual work for this problem. Now, to find the amplitude, period, and phase shift. Our amplitude is going to be the absolute value of the 3. Well, that number there, which is 3, so it's just 3. So it's going to go to a high of 3, a low of 3. Okay, in this case here, since there's no vertical shift. So you got the amplitude. What is the period? The period is 2 pi divided by 2 which is just pi. Okay. And what is the phase shift? And since it's minus.
Please excuse this interruption. Just a reminder to students, when you leave at the end of the day, be especially careful when you're walking out to your buses. And a very special reminder to our student drivers, take it slow. Don't be in a hurry. From what I understand, the roads aren't too great right now. Have a great and safe afternoon.
Be careful.
All right, it's shifted right pi over 4. And there's different ways to go about it. And if you look at the next page, it talks about how to do it by transformations, by shrinking and shifting. If you can do it that way, that's fine. But the key thing is you have to list the coordinates of these 5 key points. And it's just easier for me overall to kind of go through the procedure on the left. So this is going to be condensed from 0 to pi and then shifted. We need to list those 5 key points. So you're going to have, and you have it on your paper, you got point 1, you got point 2, you got point 3, point 4, and point 5. And we got to graph those 5 points. Well, point 1, just normally use 0, 0. Okay, we're just going to go from 0 to 2 pi, just this piece of it. Well, how has our equation affected it? Will it still be at 0, 0? Make sure you understand yes or no. Will it still be at 0, 0? No. Where will it start at, I guess? Okay, what do you think? Jaden, what do you think?
Pi over 4.
Since it's been shifted right pi over 4, you're right. Our first point will start at pi over 4, comma 0. It will not have been moved up or down at all. So it's just been shifted to the right. All right, I need the coordinates of the other points. Our period is now pi instead of 2 pi. Usually it goes from 2 pi to go from point 1 to point 5. Now it'll go pi. And this will be on that right-hand side. It tells you how to figure this out. We are going to take the period divided by 4. Okay, take the period divided by 4. The period is now pi. And what we're going to do is we're going to add that to the x coordinate to get the next point. And that's the key thing. You always take your period divided by 4, add it to the x coordinate. Well, pi over 4 plus pi over 4 is 2 pi over 4. I'm not going to reduce it here. I'll reduce it on the x-axis. What's going to be the value of the y-coordinate? Well, since it's been stretched to 3, it's just going to be a value of 3. And then I'm going to add another pi over 4. And that's going to take me to 3 pi over 4. But it's now at 0, because that's that third point. And then I add another pi over 4. Which takes me to 4 pi over 4, which is pi. And now I'll go down to negative 3, add another pi over 4. And then I get 5 pi over 4. 0. You need to graph those in just those 5 points. Now sometimes you're going to have to change your scale. You can't always use pi over 2. Sometimes you can use pi over 2. What I would do for this one is I would just extend it a little bit. I think that would be the easiest. And I would just list this as pi over 4. And then 2 pi over 4, which will reduce to pi over 2. 3 pi over 4. Pi. And I need to stretch that out a little bit more. And then 5 pi over 4. Well, I got a point at pi over 4, 0. Pi over 2, 3. 3 pi over 4, 0. Pi negative 3. 5 pi over 4, 0. So it'll look like that. That is one cycle. That is one cycle. So if you let, and it depends on how it looks, depending on how you identify your scale. Okay. And so if you just move it over, you'll have to extend your graph a little bit, which is fine for this case here. So start at 0, 0. See how it shifted. Just give me one cycle. The direction said graph one cycle. All right, there's no homework tonight. We'll finish the rest of this tomorrow.
Play music the whole time. And there's like this one activity in the first section. Yeah. I'm still confused. Really? Yeah. The last year, 5 besides your lessons together. That was not. That was not fun. Okay, I did the first year.